In this section of the right quality, we're going to be focusing on key quality control tools, which are also used in problem solving. So they're both a great way of introducing quality control, but also these are tools that you can use in any process improvement or problem solving technique. So you may have seen some of these before, maybe not, but we're going to cover some biggies here. So let's start with some mantras of quality. And the reason why I'm spending time talking about quality control tools is because of these sayings here. It is often said when you look at quality improvement or sustaining quality in a product, particularly in specification conformance, you're looking at if you can't improve something unless you can measure it. I mean, this is something simple in our daily lives. You know, I wanted to improve my level of activity and physical fitness, so I got a Fitbit so I can track my number of steps. That is I can't improve it unless I have a baseline in which I can measure it and then improve from there. And then you can't measure it unless you can see it. Using that same analogy of my Fitbit, you know, I could say, oh, I'm working out more, I'm walking more. Well, how much more am I walking? Well, I can take the extra added step of putting on some sort of pedometer to measure the number of steps. If I can't see the measurement, it didn't matter as far as being able to see if it's improving or not. Now, I can feel my general health improve, but that's a different story. Now, you can't fix it, even if you can see it, measure it, and you're ready to improve it, but you can't fix it unless you fix the root problem. Just like the story of my little Fitbit here, you know, great, I have a tool that measures my steps. Great, I can see if I'm improving in that level. But unless I fix my time management and make time for it and fix the root cause of my inability to get out there and make those 10,000 steps a day, it's going to continue to be a problem. So we're looking at tools that help you measure so you can see it and dig into the root cause. So these tools I'm going to cover today are a flowchart, cause and effect diagram, also known as an Ishikawa diagram, some control charts, check sheets, histograms, and so on. These things are very common in business, and you'll see them across multiple disciplines and different problem-solving activities. First one is one of my favorites. It's a flowchart. We're all familiar with flowcharts in some way, shape, or form if we've ever done a science project at school or, followed a process ever. In this case, this flowchart is showing that a part is received, it's painted. Then is it accepted? Is it conforming to the standard? If yes, then it's packaged. If no, it's reworked and sent back to paint. Flowcharts are great for defining a process. I don't know how many times I've gone into companies either as an employee or consultant or advisor or even as an educator to understand a process. And I said, can you show me the process flowchart? How many times they say, oh, we don't have that. I'm like, well, why not? Well, we just kind of know what the process is. Then you start to talk to people and they really don't know what that process is. In fact, maybe just one person knows what it is and they can direct everyone through it. By writing it down, we're able to see what the process is and look for areas of improvement. Also, there are various types of flowcharts. Some people are like, oh, value stream mapping or swim lane flowcharts. There's so many different ways. But the whole goal is to define the steps and the decision-making points with a start and an end point, so you can help see what the process is that you're trying to improve. Now, even if processes are followed through to completion, sometimes bad things happen. It's kind of ominous, but it's true that sometimes bad things do happen. Poor quality does exist, or defects happen. We can use a tool called a cause and effect diagram, also known as a fishbone diagram, because it kind of looks like a fish head with a bunch of ribs sticking off the spine. So you could hear it called a cause and effect. Ishikawa diagram is another name for it. What it's doing is you have a problem, in this case is poor packaging, and then you have 6 different types of areas or causes that can lead to this effect of the defect. In these 6, so you do some brainstorming, usually with a cross-functional team, to figure out what could have possibly gone wrong in the area of materials that could cause poor packaging. So we are brainstorming. This doesn't mean that these are the definite root causes, but what it does is it allows you to get all those ideas out there, because I guarantee you there will be people with different opinions as to what the root cause of the problem was. Then you investigate and rule out the ones that are not the root cause. And then when you figure out the root cause, you get rid of it. You fix it and prevent it from happening again. It's a great activity to do. You could do this at home. Why did we miss a bill payment? Go through materials, people, environment, all that kind of stuff. Don't really encourage driving your family crazy, but it can be done and used in practical environments like that. Another tool is a control chart. Now, if you've ever been to the doctor's office or the hospital, or seen someone that's ever been in the hospital that hooked to a heart monitor, we're very familiar with what a control chart is. You have in the middle the median level of performance, which is that middle range of a specification, saying that plus or minus 1, whatever 1 could be, or plus or minus a level, an average heart rate in a heart monitor. The plus would be the high end of the range, and the minus would be the low end of the range. You step out of those two control limits, the upper and lower control limits, and sirens and lights and everything gets alerted, and nurses and doctors come running in. In quality and manufacturing, similar kind of concept. You have the middle range of the specification, saying this is the normal or the mean range of performance, and then you have a standard limit for the upper and lower levels of performance. As long as you stay within those control limits, your process is in control and you're developing good product. That's the concept. Now, over time, you can see performance drift to one control limit over another. In this example, we're seeing the performance trend upwards toward the upper control limit. When quality managers see that, or quality technicians, they will work to figure out why it's drifting to that level and work to make it closer to the median. So it's a way of measuring for level improvement. Now, another tool that's very common, in fact, you probably have done this many times in your life in science experiments in school or activities, maybe even at home as you're keeping track of things. You could use a check sheet in defining or figuring out the number of occurrences for things. You have products at the top level of this check sheet here. You have product A, B, and C. Then you have some common quality issues. You have wrong lot number was shipped, dented product, broken product. And what they do is just put a little tick mark next to each occurrence of the quality issue and in the column of the appropriate product in which the issue took place. So in this case, the wrong lot happened 9 times, mostly in product C. Or dented happened the most in product A. What is the second most occurring issue? It's a good way to gather data in a very quick way, and it's simple enough that even children can use this. But it's used in manufacturing quite often as a way of taking data down for later analysis. One way to take this information and put it in a visual form so it makes a little more sense to us, because, if you're like me, I like numbers and all, but this really doesn't mean much to me, and I like to see the visual side of it and compare. There's no correlation between the previous slide and this one, but what I'm demonstrating here is a histogram. You would take data from a check sheet and plot it in the level of frequency. So in this case, the issue number 1 had less than a 10% frequency. Number 2, a little over 10%. 3, clearly above 50%. This is a predominant issue. 4 and 5. Now, you may assign issues or quality defects at the bottom here instead of a numerical value. And some people I like to put people's names there. Yeah, don't encourage that. But either way, it's a way of visually representing the data that you've gathered through the check sheet. Now, taking this histogram to the next level, you can do what we call a Pareto. It's just a simple way of sorting your histogram in the highest number of occurrences through the least number of occurrences. The Pareto diagram helps you achieve some analysis through the 80-20 rule. The 80-20 rule is something that is commonly used in business. It says that 80% of your problems come from 20% of your quality issues or suppliers or customers. It's the math is transferable when it comes to all kinds of issues, not even quality ones. It says 80% of your sales comes from 20% of your customers. Same kind of concept. The whole point is to focus on the significant few. So that 20% of the quality issues, and then you deal with those, and things will improve dramatically in comparison to focusing on 80% of the issues that only have an impact on 20% of the overall quality. In this case, this histogram has been sorted. It is considered a Pareto diagram because it does show that nice slope from the left-hand side down to the right-hand side. Poorly packaged product is the number one complaint at 40%. Then you have late deliveries and on through. Quite often in business, and I've dealt with this many, many, many times, someone will have an opinion because some customer has been screaming at you or your management for some time about, this particular quality issue. This is the number one issue. And when you do the math and you actually Pareto it out and you realize it's not the number one issue that's causing you the most quality issues. Yes, you still need to address that customer, but if you really want to improve quality, you need to focus on the significant few as opposed to these insignificant many. So it's a very powerful tool and commonly used. Another tool is a scatter diagram. So it's taking that data of the check sheet, and you may have this more over a linear factor. So a linear factor of time. So in this case, days of the month here at the bottom, and then you have the number of goods packaged. So over the course of a month, they plotted a number for each day showing how many goods have been packaged. Now what a scatter diagram can do is show you trend. It can show you if there's any correlation between the days, and in this case the days and the number of goods packaged. And we see here is an upward trend. You see how those dots are moving gradually from the bottom left-hand corner to the upper right-hand corner. So that means more goods are packaged towards the end of the month than the beginning of the month. I wonder why that is. I'd have to do some digging, maybe do some cause and effect diagram to figure out what was going on there. So those are all the quality control tools we're going to cover today. I can tell you that they are used in various forms of business, various activities, not just quality, but commonly if we're looking to improve the quality of our product, eliminating defects, removing the issues that are causing us from having to stop and look as to why the customer is not buying our product because it's poor quality or sending it back. We need to be able to measure it, improve it, and find ways to improve it. So, just to make sure we did what we were supposed to do here, we have identified some key quality control tools. If you have any questions, please feel free to reach out. I'd like to give you more examples. If you want to have some real-world application of these, feel free to share your ideas. I'd like to hear from you. I'm available anytime. Just email, call, or text. Thank you, and I look forward to sharing the next part of the presentation with you, which is the cost factors related with poor quality and how quality and purchasing are impacted together. So thank you, and have a great week.